Welcome back to Let's Discuss. And it's Sunday, which means this video is dedicated to helping you guys with your goals. In this video, we're going to be talking about what it's like to major in aerospace engineering. And I have Josh Thompson here as my guest, and I'm going to allow him to introduce himself.
Hey, my name is Josh Thompson. I'm an aerospace engineering major at University of Alabama in Huntsville. It's my junior year, and I'm from Mobile, Alabama.
All right, stay tuned, and let's discuss aerospace engineering. So, Josh, first question, what is aerospace?
So aerospace is more or less very similar to mechanical engineering. You're designing, building, analyzing structures that are more specific to aircraft, spacecraft, and other hardware that will be used in space. Like SpaceX is full of aerospace engineers to build the rockets. The people who build the Mars rovers were probably some aerospace engineers, because you have to use we use a lot more aerodynamics than mechanical engineers do.
Okay. What are the different careers you can get from an aerospace engineering degree?
So generally it's pretty versatile. Really any engineering degree is pretty versatile, but generally you would get something like maybe a mechanical engineering slot, where you're designing the body of a spacecraft or the body of an aircraft or the body of a car. You would maybe even be doing modeling and simulation. That's kind of a piece of designing, the designing process where they get all the numbers correct. Modeling sims people are very precise as far as what's going to happen, when it's going to happen, when is it going to break, how much can you use it, when is this thing going to wear out, what materials should you use, and the designers, which is another part you can get into, CAD designing, which is 3D designing, is where you actually get the structure, the body, where you'll also be doing some statics and dynamics, which is stress analysis and those kind of things. You can also get into systems engineering, where you're looking at the system as a whole. That's kind of like saying, okay, say if someone wanted to design a table, tables don't exist, no one knows what a table is, and they're like, okay, we need something that holds an object, and you're like, all right. So a systems engineer would be like, okay, we need something that can have a flat surface, has 4 legs, is brown. That's just engineering. And then, how much weight can it hold? How much weight is required to hold it? That's systems engineering. Very, 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 very top level, very generic. And that's when it goes next to the model and sim engineers, and they're like, okay, you need this much thrust, or So then to the design engineers, like, okay, this is how you make this much thrust. So it's very versatile. Really, any part of engineering process as it comes to spacecraft, aerodynamics, thermodynamics, you could get with the aerospace engineering degree.
Okay. Why did you personally pick this major?
I picked it because when I was little, I wanted to be an astronomer, and then as I got older, I liked to build stuff, and I didn't know what an engineer was. And then my mom was like, "You like space and you like to build stuff. You should be an aerospace engineer." And I was like, "All right."
Okay. What type of courses are covered in your aerospace curriculum?
So you'll take some thermodynamics, you'll take some static dynamics. Thermodynamics is the study of heat transfer, that kind of thing. How something gets hot, cold, what is heat, what is cold. You'll take a lot of maths, you'll take all the calculuses, you'll take some coding classes. You'll take some high-level math classes. I mean, our curriculum here at UAH, we're one math class away from a math minor. So we basically take all of our math classes that don't get into proofs and run with that. So you go all the way up to differential equations, actually numerical methods, which is a coding class using MATLAB. You can argue MATLAB is a coding or not, but using MATLAB, and you also take so dynamics, which is the study of things that move, statics, study of things that don't move. Mechanics of materials, which is statics on steroids. That's the study of the type of materials. So how does it break when it's not moving? You'll take some design analysis classes. really, there's a lot of classes that you take. You take some compressibles, aerospace compressibles, see how wind works, how aerodynamics works, how what thrust is. You also take a lot of systems classes that involve aerospace. So like the top to bottom level of how a rocket works kind of class. You'll take them on 2 classes, at least in Alabama.
Yeah. What would you say are some of the pros and some of the cons that come with this major?
So the pros. There are no pros. Why am I doing it? The pros are.
It'd be like that sometimes.
You know what? I'm checking out major today. No, I would say you're doing some really cool stuff. Like you're doing some stuff that a lot of people do not see happen. Like, and that they just, someone who's not an engineer would look at that and be like, oh, that's just what it is. But an engineer could be like, oh, it's happening because of this and that. Like an engineer could break it down. Yeah. 3-dimensionally and be like, oh, this is why it happened. You're like, you know why your tire pressure light comes on when it's cold outside? It's because the density of the air in the tire is changing. Like, an engineer will get some. They'll think of different stuff differently. You take some really cool math. If you like math, you can take some really cool math classes. I wasn't a fan of math coming in, but after I took all my calculuses and glad that I'm done with them. I think math's actually pretty cool. So I think I was just, it was probably some propaganda from my math teachers, but I think it ended up being pretty cool. You take some physics classes, seeing how things work, why they work. There'll be some, like, even some designing things that you're doing, you'll be like, why is it like that? Like the velocity, like if you want something that I would have thought was different, which actually ends up making sense, but like, if you want something to move faster through a pipe, you want the velocity to increase, the pipe actually needs to be smaller, but you're moving less mass, so you run into a weird problem. And then, so you'll look at AC units and be like, oh, that's why it's that size or whatever. But you do some really cool stuff. I guess the cons are you think pretty one-dimensionally. If you don't, I say with any STEM major, if you're going to a STEM major, also have a liberal arts minor, so that you can think more open. Because engineering is like, okay, this is the answer. This is your answer. It's 34. Like, there's no arguing with it. But like a liberal arts minor, like my minor is political science, the questions become, okay, what is the answer and why? And then you both have 2 different answers, but you're both correct. As long as your fundamental facts are right, you're both correct, even if you went 2 different directions. So then that can help you when you're in your design. When you're designing, you're going to the design field of, okay, there's not one way to design this thing. There's multiple ways to design it and they're all correct. And you can back it up with the hard math to be like, okay, this is the number, but I went this direction and I went this direction because of this. Where most engineers won't be able to do that because they just took engineering classes, maybe did a math minor, and they're thinking one-dimensionally of like, this is the answer, this is how it looks. And you're like, okay, this is how every car looks. Can you make the car look cooler? Like, why? Yeah.
Can you make it different?
Can you make it any different?
The same thing a different way.
And they're like, because at that point you're really just a machine, and nothing's wrong with being that, because you need the people who just crunch numbers and stuff. But you also need the people who could think. Engineers think 3-dimensionally. Liberal arts people think like 5-dimensionally. Like you need somebody that could broaden. Like, okay, this is why I did it.
Right.
So that's a con. Is that if you don't diversify your brain, you'll be a machine. And nothing's wrong with being a machine. You'll just be stuck in the basement working numbers and stuff. But that's fine. That's fine. You'll be making good money.
What would you say is and you might have already answered that, but what would you say has been your biggest challenge so far?
Greatest challenge? Greatest challenge is time management. The engineering workload as a whole is crazy. It's ginormous. I mean, if you don't have discipline, you're not going to pass the classes. If you don't say, okay, I got to wake up early, like, because you also got to live your life as well. So you got to work out, you got to have a social life, you got to do things that you want to do on the side. So if you want to do all that, you could be a hermit and just, I mean, there's like I got UH. There's 2 types of people, 2 types of engineers. There's the ones that, and I would say only 5% of the engineers do other stuff, which is fine because all of them end up getting jobs. But like, if you could be an engineer that just studies, gets a 4.0, no clubs, no nothing. Go in your room, study 4.0, whatever. And that's all good, happy and dandy. But then you also, if you want to take it to the next level, should be able to go, do more things outside of that. Have friends, for one. And then work out so you don't end up like a fat bum or a skinny bum. And then do things outside of that. And to do that, you're going to have to wake up early sometimes. You have to wake up at 6 o'clock and go for a run because you also got to study. You might have work, so you got to be able to discipline yourself at least for these 4 or 5 years. And another thing is, don't go into engineering thinking you're going to graduate in 4 years. Now, it's not going to happen. Especially if you're doing it right, because if you get a co-op, you're not going to graduate in 4 years, but for a great reason. You got a job,
Right.
You got an internship. You might cut your hours back in class, so you can put hours at the internship. But that's a great reason. You're getting more you're getting more real world experience. So don't go into engineering thinking I'm going to graduate in 4 years and get out, because that's not the best case scenario in actuality.
Do you have any last, just general advice for success in this major?
I would say, as for advice for success in engineering, aerospace engineering, one, make sure you separate your work and your personal life. As far as like when you're doing homework, When you're not, do something else. Distract yourself. Go hiking, go fishing, go golfing, go read a book, something. And also make sure you're doing your work when it is time to do your work. Don't try not to get distracted.
Do your work.
Yeah, like when it is time to do your work.
Don't procrastinate. Do your work.
Because engineers procrastinate and I procrastinate. And also don't get a coffee addiction. I'm like a crackhead right now to coffee. So like my eyes start twitching, I start scratching. I'm like, I need a cup of coffee. Don't gain an addiction. And also just enjoy it, because it goes by quick. That was I graduate next year. I kind of don't want to, because I didn't get to experience college because it's COVID. I should fail a class or two so I could do it again.
Yeah, that's it for us today. This is Josh Thompson, everyone. Thank you for being a guest on the show. You can follow him on Instagram at president. And in this video, we discussed what it's like majoring in aerospace engineering. Leave a like if you think it was helpful. Share this video to anyone else that is also interested in the major. Leave a comment down below with other videos you'd like to see me do, and subscribe so you don't miss any more videos from my channel. That's it today, and I'll talk to you later.
All right.